Art and Build, we've been around for 30 years or so. We're an architectural practice based in Paris, in Luxembourg, and in Brussels. My training was as a biologist before I became an architect. I always say that because when I make presentations, there's an awful lot of reference to the biological world, and people often say, well, you know, how do you know where to go looking in the biological world in order to find inspirational ideas that nature has had, or solutions? And for me, it's quite intuitive, because for some reason the biology training stuck in my mind. So then I became an architect, and becoming an architect is really about trying to transfer the wonderful intelligence, this phenomenal smartness is a word that we use a lot now, how we transfer that smartness into the buildings in the cities of today without having to resort to extremely high-tech solutions all the time. We think that we can go for a much simpler approach. I'm going to talk today about one stream of research in particular. We have 4 streams at the office. The first is bioeconomy, which is going to be today's subject, how to think about the recycling, upcycling of materials that we put into our buildings in the design process. So we anticipate what will become, what their third life will be. The first life being the raw material, second life the building, third life being the after. We also have a stream in biodiversity, one in bioresources, which is particularly addressing materials which come from the biological world. So timber, hemp, there are an awful lot of them around, and they're becoming more and more important all the time. And biomimicry, which is really an approach to look more closely at the formal ways in which nature responds in almost a sculptural way and in a dynamic way to solving its problems and to making its own structures more efficient. So I stuck to your format here with a PowerPoint, so I hope this is going to be okay, but I'm not going to read through all of this. But basically, today's presentation will be about how to use CLT panels, or how to anticipate the reuse of CLT panels. CLT panels, for those of you who are not in the business and don't know the jargon, this is cross-laminated timber. There's a big move towards timber construction. We've got terrible habits in the building industry of using much too much concrete. It's nice to see Frédéric Chartier, some wonderful timber buildings being built right now and have been built. So it's nice to see that this movement is really taking off. CLT, I'm going to go straight to why we chose the CLT. CLT is becoming now the go-to product when we start building office buildings, housing. It's a great floor slab substitute for a concrete floor slab. So cross-laminated timber, these are big chunks of timber. This is a project which a competition which we won, I think, in 2012, and which we handed over in 2017. It's in the Porte d'Ivry, if you know this part of Paris. A very visible site, but also a site which suffers quite a lot from noise pollution and all of the problems that come with being next to the périphérique. When we initially designed this building, we were told by the environmental consultants, Franck Boutet, that at the end of the building's life, we were expected to burn the timber and recuperate the calories. Now, this seemed to us absolutely nonsensical, but that's what the calculation was asking us to do. That's what they expected buildings, when they arrive at the end of their life, to happen, to be burnt and to be used in a different way. We thought, this is crazy. There has to be a way to recycle the timber elements, and particularly the floor slabs, at the end of the building's life, and to do something valuable with them so that we keep that carbon sequestered and that we don't have to burn it. So we started thinking hard about what we could do with the timber. And this really became the source of the inspiration for the research project. About that point in time, I met a student who was doing her end of year diploma at the Paris Marquet School, Louise de Guine, who told me about lattice hinging. And lattice hinging is one of these wonderful techniques used by instrument makers in the past to curve wood. This is a subtractive technique. there are tools which we can use today to upgrade that technique and apply it using parametric digital tools to timber products, to conventional timber products which we use today. We thought, wouldn't that be great if we could take a floor slab and we could cut it, we could analyze it first of all for its structural capacity, then cut it in a particular way. Perhaps we could use those timber elements and make something even more interesting than just a simple floor slab. So we had a look at the algorithms that were available and the parametric tools that were available, and we understood that there were certain calculations that had to be made depending on the species of the wood and depending on the thickness. And this is all about how you put certain elements of the timber or certain elements of the wood into torsion. So we got our engineers on board and we started looking at that a bit harder. We then started to look at what tools were available, whether it's circular saws or whether it's fraiseuses. Lots of different things available, different sizes of machines, obviously different sizes of robots, which could enable this transformation to occur. So we started to do a little bit of experimenting. And the first result of the experiment was actually the hall of the building which you just saw, which was handed over in 2017. This, though, was an application which was very modest. This is just a decorative application, but still it gave us a pretty good insight into what sort of tools we would need, and when we were upscaling towards timber slabs, what we would need to do in order to get a feasibility study done and to move one step forward. At this point, there was a bio-inspiration moment. I don't know if any of you recognize this diagram, but it's the double membrane, the bilipid membrane, which forms basically the architecture of all cell walls in the biological world. It's a phenomenal structure. It's a phenomenal principle on its own, but I'm not going to go into it. But it did make us think a little bit about when we recycle our timber slabs, when we start making these new structural elements, could we not think of a double wall rather than a simple wall? Generally speaking, structural walls tend to be one element which does all the work. Could we not be more efficient with the use of matter and divide that material into two, create a cavity? Into that cavity, we can put all sorts of things. We can pierce the double membrane with our windows and with different things that we need to get from the inside to the outside. Could we not develop a double membrane system out of our timber slabs? And that's what we started to do. The first concept models, you can see here that the cuts that are made into the vertical slabs of timber correspond to the ability to curve it. So if we have cuts like that, we end up with an object which looks a little bit like that. So these are 6 centimeter CLT slabs. This is about the thickest that we could go to in terms of the current standard machining tools, standard practices for CNC. And we were pretty happy with that. We actually had on our hands a real structural concept. And the double wall was also very attractive because we thought, well, yes, we can run all sorts of the nitty-gritty bits of architecture, the vertical stacking and the tubes and the pipes and the insulation, acoustic insulation. We could stick it all in there and we could get something which could become a really viable and sculpturally interesting principle for future buildings, for the third life of the tree, if you like. So just a quick reminder of when we started benchmarking this process, the aspects, the positive aspects that we were looking at. So we have, first of all, a reversible bending process. We're transporting our timber slabs flat, and then we bend them in situ. So again, we're dealing with a considerable improvement to the way in which we transport materials to the construction site from the lab. If we get them flat, ship them, and then bend them inside, we're making a considerable economy in terms of the way that the energy used for transporting. So that's the third point, less energy consuming. Of course, this is a cold process because we're just using machines in order to transform the timber. We're not using heat presses and conventional bending mechanisms, big jigs, which are not particularly good and sometimes very, very expensive from a carbon point of view. We're linking digital manufacturing. So I was talking about parametric tools and CNCs. We're linking that with work on timber elements, which is taking things a little bit further compared to traditional timber and carpentry techniques. We've got the custom bending. So basically, using these digital tools, we can make the curves that we want just by modifying the parametrics in the equation when we start analyzing what it is that we want case by case. And then we're doing this thing, which was the initial reason for doing it. We're allowing for an upcycling. We're opening a new stream as to how to upcycle material at the end of the life of a building. Given that we are surrounded now by people, clients who tell us that 20 years after delivering their first buildings, they're now dismantling them, and they wish they'd thought more about the dismantling when they designed them in the first place. Then, of course, there are all the lovely aspects of timber, the biophilic aspects. Biophilic is another bio prefix, which I'm sure you'll be hearing more and more of as time goes on. We were then asked to design a pavilion, a welcome pavilion, for the equivalent of the Salon d'Agriculture, the agricultural fair in Belgium. This takes place every 2 years in a place called Librement. They asked us for a welcome pavilion, and we thought, well, can we not take our process of CLT bending one step further and design the pavilion? This pavilion would then have to welcome the public, which introduces a number of new rules which you have to respect. And of course, I think if there are any architects listening, you'll understand what the constraints involved with having to validate your structure in order to have a certain number of people come and visit the building. So another biomimetic moment, we then sort of started to think, well, what curved structures are there in nature which could offer us a solution, an application for this particular pavilion? We looked at bone. Bone is very heavy. It takes a long, long time to grow. Concentric circles, it's lovely stuff, but it's very, very matter intensive. When I was a kid growing up in Jamaica, I remember hurricanes coming through the island and knocking down all of the banana trees, banana plantations, which would then spring up again. A year later, we had plantations of bananas, and I always wondered, how does that happen? How can the banana tree, it's not really a tree, how can these stems grow so fast? When you cut through them, you begin to understand, and that's the figure on the right. That's a section through the banana trunk. It is a series of concentric circles, but a lot less matter for the structural capabilities. So the ratio is much, much higher. So we started to look at this. If you take a look at the section, you understand that you've got these concentric circles, which are based on a displacement every 80 degrees, more or less, as the fronds come off, but that adds a certain level of structural capacity. And then you've got these braces, which are laterally giving more support to the structure. We designed a structure based on that, where we used the stair treads in order to replace the lateral bracing. This gave rise to our first model, which was done with a small CNC machine, and it enabled us to get the parametric tools more or less sorted out. And then the pavilion, which was built in 2019, for the summer of 2019. So that gives you an idea of how you can take the principle and then you can work it up. Obviously, I'm going through a very accelerated path, work it up to something which becomes an element, an architectural element. This, you may wonder why we cut it off absolutely flat at the top. Well, this is because the idea is this is a section of a structural element which could be asked to do something much bigger than that. We also discovered, going through this process, what a beautiful aesthetic piece this procedure, this subtractive procedure can offer us. So in a way, the architectural sensation comes back into the process quite a bit later, after you've gone through all of the technical and the intellectual hurdles in order to get this stuff built. The architecture comes back to work all of its magic on you. And there is the structure working its magic on our Belgian friends. The work, what we're doing now on this particular structural principle, is benchmarking. If we wanted to do exactly the same thing with a conventional post and beam structure or a stud frame, what would the carbon imprint be? How much time would it take? What would be the options available to us in terms of the choice of timber, etc., etc. So benchmarking is also a very important process in terms of design, to find out whether or not you're heading in the right direction. But of course, this is recycled timber, so already you're starting from a very, very beneficial carbon footprint by not having to go out and cut down trees again. And then the third and final project, which is the most recent manifestation of this research, the Grand Palais Éphémère. So this is this summer. It's being built right now. It's Wilmot who has designed it. It's a huge structure, timber structure. It's magnificent. If you ever go down the Champ de Mars and you get a chance to have a look in, it's absolutely wonderful. This will then open to the public late spring. We were asked to design the temporary amphitheater on the inside of the building for the Forum Bois Construction, so which is an event which is held usually annually, and a big meetup for all of the people, timber actors across Europe in particular, and even some come from around the world. The request was to design the theater, which was going to be right in the middle of this. The middle of the Grand Palais Éphémère, and the red rectangle gives you an idea of where it's going to be. We, of course, went straight to our timber bending process and thought, what can we do with our panels now in order to create a sort of enclosure which will become the basis of this theater. The theater primarily existing in order to protect a certain area, to give a certain level of intimacy for the speakers and for the different conferences which will be held in the Grand Palais Éphémère. So we came up with this idea of a sort of a timber rigid curtain, which is going to surround the 300 or so seated places and the stage. The question was then, how do we get all these things to stand up and work together as one simple structure? That's a view of the inside. Quick view of the outside. It's about just over 5 meters tall. So these are very, very big panels. Again, 6 centimeters CLT. The inspiration for the structure came this time from bird bones. Bird bones are also phenomenal in terms of the efficiency of matter compared to the rigidity which they supply. That seems kind of obvious when you think that a bird is not going to fly very well if its bones are too heavy, but these are marvelous structures when you have a look at the inside. So we thought, well, perhaps we can use this elegance of the cross bracing in order to hold the timber pieces and make all of the timber pieces individually stood up timber pieces work together as one sort of exoskeleton. And that's what we asked the engineers to do, and that's pretty much what's going to happen as we go through the process of refining the design now for the building's erection in this spring and this summer. Little view of what it looks like from the top. 1 or 2 views of the engineer's calculations. These things, again, have to go through an awful lot of hurdles in order to get approval, because after all, you're going to have the general public who will come to visit. And on all of this testing has to be done before you put the wood into the machines in order to start cutting it up. There's our first test piece, which is being braced using a series of horizontal cables, which are going to hold it into the curved shape. So we don't have any jigs or any other horizontal elements holding it, which is a slight difference from the project which you saw initially, the sort of the drum-shaped notice Sylvestre. And then that's what it's going to look like, hopefully, in the inside of Wilmot's Grand Palais Éphémère when the project is completed. So again, COVID-19 permitting, it would be wonderful if for anybody listening who is available to come in late July to the Grand Palais Éphémère and to see not only our amphitheater, which is just one piece of the show, obviously, but to discover some of those other wonderful projects which are being built in France and around Europe at the moment. We also dream a little bit. Obviously, we're architects, and I think we haven't lost track of utopia. This project, we're hoping that perhaps one day we can imagine structures which are not just one-dimensional curves, but two-dimensional curves. So we're still looking at our old friend, the banana tree, and we're now working with engineers on the parametrics of trying to introduce a double curve into that bending mechanism, which opens up a number of different possibilities in terms of where architecture can go and what structure can offer us to our buildings. So when we think, yes, what will our cities look like in 100 years' time? Well, this is a bit of a dream shot. I mean, perhaps we could imagine that we can extract our bioresources straight from our landscape around us, and perhaps we can use the intelligence of our numerical tools. Perhaps we can get all of these things fitted together, and we can produce buildings and habitats which are quite different from anything that we see today. Thank you very much. I have no idea if I've run way over the time, but I'm going to hand the microphone back to you.
Thank you very much. Thank you very much. It was very, very rich presentation. We can see have several insights on how your work are reimagining a little bit the architecture and having positive impacts. We have one question. I work for the European New Bauhaus partner. My question: are all presenters in the second part presented free of charge? Yes, all presenters here are free of charge. I don't know if you have more questions in the chat right now. No, maybe we can, I believe we can have some questions for Steven.
Yeah, thank you for focusing on this project, and we know that you are working on many different biomimetics projects. Maybe can you tell us a little bit about your approach in general? Do you replicate that approach for every project, or how do you look for the biological models, for instance? I know some other projects are inspired by different living systems. Can you tell a little bit more about these methods?
I think I spoke about the 4 streams of research. We try to practice what we call, very modestly, I think, bio-inspired architecture. So architecture is the coming together of many, many different things, from the resourcing, where you get your resources from, the impact that your extraction of resources will have on the environment, the notion of time, in the building coming to fruition, coming to life, and then what will happen when it comes to the end of its life, which buildings inevitably do. The integration of biodiversity. I mean, a lot of these things actually Frédéric Chartier touched on in his work too. When you see a section of a timber building which he's designed, which will have biodiversity on the balcony, that is not done just by clicking your fingers. He knows that to get biodiversity into timber buildings, you have to go through a whole bunch of new hurdles, because you're bringing water into a place where water is not welcome. So, you know, our work tends to try to make linkages between the intuitions that we have in our 4 lab streams. So it's not just a question of saying, okay, I really want to try and do this. It's, if I do this, what will the impact be on the other aspects of design? If I make a really good facade, or if I choose to use timber in my building, what will be the impact on other aspects of conventional design? So we're constantly looking to see how we can fit the different biological principles together and to make something coherent. We're a long way away from that yet, from the perfect building, as it were, but that's our goal, is to try and see how we can fit these bioprefixes together. I think that's the real challenge. It comes back to the definition of the word architect, actually, in a way. It's a synthetic practice. It's putting things together, finding out how things mesh.
Great, thank you. I have one question also. It's mostly regarding your clients. So there are such innovative approaches. Do you feel some barriers today from project owners to this kind of new approach of using and applying biomimicry and applying regenerative design?
Yes, definitely. I think that generally speaking, the building industry does not like risk. That was one of the things that we dealt with our first timber buildings. I think we're now in our 3rd generation of timber building. The last one we just handed over for a big automobile manufacturer. I'm not allowed to say the name, but it's 12,000 square meters of pure timber. So, and that was the first time we had a client come to us and say, we want timber. it has to be in timber. Generally speaking, we were coming forward and saying we can put timber on the table as an option. We believe that this is the right place for timber, but now clients are actually coming to us. So I think the industry has moved past the initial elements of risk in order to say, yes, we can do these things. Now we have to do the same with all of our different branches of research, eliminating that risk and saying that now the challenge is worth taking. We can handle the economic aspects, we can handle the technical aspects, we can handle the compliance with building code aspects. And I think that's, and the public perception aspects, you know, wood burns, wood rots, wood gets infected by termites and all these sort of things. You know, we've gone through many of those hurdles. And I think biomimicry in general has to learn how to get through those hurdles in public perception and in industry perception.
Yeah, sure. Thank you very much. I believe we have no more questions in the chat. So thank you very much, Steven. It was a pleasure to have you here today.